So our last talk of the day will be from the Allotrope product team. Our senior developer, semantic engineer, Ben Woolford-Lim, will take us through a summary of where Allotrope has been in the last quarter and what's coming up in the next quarter. As hopefully those are familiar with Allotrope know, we've had a record of quarterly releases of content really for several years now. For those who aren't familiar and are new to Allotrope, Ben hopefully will give you some context of basically how the operations work and what you can, the kinds of things you can expect to see as output every quarter.
So an update on what Allotrope's done in the last 2 months, 6 months since the Spring Connect, particularly what the working groups have done and what our releases have been. So for the quarterly releases, Q2 and Q3, we've had a few new models in, so Q2 at the top, Q3 at the bottom. So brand new models, things like solution NMR, electrophoresis, chromatography columns. I'm going to go into a little more detail on the relevant slides. We've also done quite a few model updates. So as part of our efforts to harmonize and improve the models, we have a modularization approach. I'll again touch on a little bit later. So we've done various updates to models, some of them of which are that modularization process, some of which are improvements that have been suggested through the community, light obscuration being one, and sometimes just the odd little bug fix here or there, because at the moment it's all being done by humans. We don't currently have that Gen AI in place to do things properly and correctly, and definitely without any hallucinations that could go wrong. That screen. So for the Q3 release, we have it available on the usual places, GitLab for both AFO and ASM ADM. The ASM public repo is available for anyone who's not an Allotrope member, so AFO and ASM are both publicly available to the wide world, but the internal development repositories are Allotrope member only. So the ASM public repo is where we store the ASMs for the whole world to view. We also have the Perl server that's been mentioned earlier. We have a JFrog Artifactory that all of these things get packaged up and put, as well as Client Connect and the Allotrope website. In addition to that, the ontologies are all stored on everyone's favorite ontology lookup services. So Allotrope directly interacts with 3 of them: BioPortal, OntoB, and the ontology lookup service, OLS4. We're actually spidered on a couple of others as well indirectly, so we've been pulled through from presumably one or more of those to a couple of other places. So it turns out Allotrope's kind of getting a little bit more traction outside the ones that we directly support. So if you're interested in the ontologies, go take a look at one of the ontology lookup services. And if you're interested in the ASMs, you can grab them straight from GitLab. As I mentioned, our modularization efforts continue. So we have a common hierarchy that we apply consistently across all the different techniques to bring that sort of harmonization across analytical techniques. It doesn't matter whether you're doing a balance weighing or a pH measurement or a high-end mass spec. There's a measurement being done. There's a sample. There's some data that's coming out at the end. There's probably some device control settings to saying this is what we told it to do and this is what came out. There's commonalities, and so in order to make those consistent across the entire suite of models, and not incidentally to make it easier to then build new models following those same patterns, we have the common hierarchy modules that basically let us enforce those consistently across the patch. So we've been applying those throughout the suite of models and expanding them based on needs and use cases as we discover there are things we want to add that again become common. Things like the custom information document that's been mentioned a few times today. That's one of the things that have been added in more recent versions as we've learned, we need a place for custom information that's not actually part of Allotrope in the common core. We also have the DevOps pipeline. So the product team is fairly small, I'll say. So we have a whole bunch of tooling to try and help us push out all of these models on a regular cadence, and as Vinny alluded to, our nice quarterly release cycle to make it easier to do that. We have continuous integration, continuous development pipelines, both of which are hosted on GitLab, again publicly accessible for the publicly accessible to the community those ones are on the internal repository, so they're not available to the wide public. But you can take a look and see. And what they do is provide things like QC, QA checks, and help to automate the deployment to enable us to do the difficult work, the non-routine stuff with the resource we have. So maintenance work on that's been ongoing in the last couple of quarters. We've been working on improving the Perl stability. I think someone mentioned that earlier. So we've been working on helping to fix that. A couple of updates to Fuseki to make it, bring it up to the latest version, fixing some disk space issues. We've done a little bit of security, enabling HTTPS on that because the original version was using HTTP. We still support both so that it doesn't break any existing usages. So if anyone's worried that suddenly they're going to start seeing SSL errors, fear not, we covered you. One of the larger changes we've done in the last couple of quarters is work on aligning the AFO and ADM repositories versioning structure with Git. Previously, we would actually store everything in its own folder. So 2024-06 had a folder, 2024-09 had a folder, in the same way that you see it on, the versions are in the Perl server and in the strings for the manifests themselves. We stored it that way in the Git repository, which was fine to start with, and it started getting larger and more unwieldy as we have a copy of 2024-06 that's had a few changes, and now it's 2024-09. More to the point, that also tended to break existing Git tooling. You couldn't then compare one version of the file to the previous version of the file because they're actually different files. Git doesn't play well with that. So one of the more recent efforts we've done is to try and clean and tidy that up, so we can use more standard Git tooling. So it's a bit more convenient if you're used to using Git and actually leveraging it as the version control software it's meant to be, as well as just a few QA enhancements as we go. So a little bit on the DevOps work is ongoing to try and keep our resource focused on the interesting stuff, the stuff that we actually want to get done, which brings us on to the working group updates. So most of our work is done through these working groups, the weekly or bi-weekly meetings of our SMEs, our scientists, ontologists, techies, me, and this is where the sausage gets made, as they say. So the modelling working group is where sort of general modelling gets done. If you're not sure where you want to bring a new model, generally speaking, it's to the modelling working group. That meets weekly, as you can see, on Wednesdays. If anyone isn't on that group and wants to join, or in fact, for any of the groups, if you're interested and want to join, please just reach out to Aminon or myself, and we can get you added to the list. So, the modelling group, what we did, what we're doing, and what we're going to do. So this in the last 6 months, we've released 3 of those new models: solution NMR, electrophoresis, and rheology. And the group was involved in 6 of those model updates. One of the large ones being automated reactors. That was a pre-existing model that was frankly huge, and that's had a major revision to bring it up to the current standards of allotrope modularization, so those common hierarchy patterns that I discussed previously. As an older model and a particularly large model, that was a very large effort by that group, so kudos to the working group for pushing that through, I'd say. This quarter, as has been mentioned earlier, Benchling has put forward binding affinity as a model of interest. So we're looking at surface plasmon resonance specifically as the first detector there. That one is going to be in working draft because one of the things we're discussing is an extension to our data cube pattern to potentially allow externalizing of it into a separate file. So this is something that we've discussed loosely in the past, and we now have the concrete use case to explore it in more detail. The idea of taking the data cube, the raw data that everyone wants, which is generally sometimes doable in a JSON file, a text-based ASCII file, but can sometimes be a bit large and unwieldy. So the idea of then using that externalization approach that we've used in several other approaches, or several other spots, and basically going, and here is the external data in some format to be specified. So we're looking at that approach. We'll see if we can't put a working draft out of that for review by the end of the quarter, and then push that into candidate rec and full rec sometime in 2025. Alongside that, next year, at some point, we'll look at calibration. This is something that's been discussed a few times. There's interest in multi-angle light scattering, MELS, liquid handling. We've got an update to the optical microscopy model. We have some new imaging patterns that we want to refresh that model to include, and then update to the X-ray diffraction model to include our hierarchy patterns as mentioned. So plenty on the agenda. And again, if any of these things happen to interest you, please reach out. We can get you added to those working groups, and you can, weigh in and make sure that it meets your needs as well as the needs of whoever's currently pushing them. So for the chromatography working group, again, every 2 weeks and a Monday, just say if you want to join. We've been working on the chromatography column model. That's in conjunction particularly with Dwight Stoll from Gustavus Adolphus College. For those who know chromatography, you're probably aware of the HPLC columns website, the database that lets you compare column equivalents using the hydrophobic subtraction model. He's the one that manages and runs that, and he's been giving his input for the chromatography column model to basically record that information so that you can have that in an ASM form and be able to do your comparisons of your columns to go, yeah, okay, we need to switch out, let's use that one. So we're trying to bring that construct into the allotrope fold. We also worked on reviewing 2 of the models produced by other groups, the electrophoresis model that I mentioned from the modeling working group. Because a lot of electrophoresis is done via chromatography data systems, it makes sense for the chromatography working group to do that review there. And similarly, Lablicate pushed a GCMS model through the mass spec group, which I'll touch on later, and being as it's GC, gas chromatography as well as mass spec, a review made sense. Currently, we're looking at the modularization of the chromatography models. As I said, we have common patterns. We have some commonality between the chromatography stuff. We have a chromatography detectors module sort of below that common hierarchy. We're looking to see if we can enhance it further, have some a bit more commonality between, say, gas chromatography and liquid chromatography. And as well as that, because of that, the way the modularization is done, due to limitations in JSON schema, we have a lot of excess content, I'll say, in some of our models, because it basically has to support all the possible detectors, which means you have the option of all of the different detectors when you're trying to do, say, GCFID. You still see things for absorbance, as an example. So we're looking to see if there are many approaches we can take that try and reduce that without being sort of too much of a huge change to the existing structures. So again, 2025, we're looking at, I think, adding moles as a detector to chromatography. We're also looking at size exclusion, supercritical fluid, and we're looking at gradients. So one of the things that we opted out of including in the original scope of chromatography models was the gradient tables. The primary focus was interpreting the data, and the decision at the time was that gradient tables, whilst useful, didn't contribute enough to be worth including that in the structure. We're now mature enough that we want to consider that, and we're also finding there are other techniques that need that kind of data. So we're looking to see if we can't build a pan to, again, do that consistently across both chromatography and the other techniques that have this kind of, data over time, settings over time, I should say. We have data over time already, but settings over time, which is a slightly different concept in the ontology. So mass spec, as I said, the mass spec group brought out the GCMS model. Thanks to Matthias for pushing that one forward. So bringing the GC detector, the GC model with the MS detector together. As mentioned, there was a fair bit of work on how to represent the data cubes in an efficient way. There's a lot, when you have a large, sparse mass spec data set, there's basically a whole lot of zeros. You don't want to have to put that into a file. What's the point? ADF has a structure for sparse data cubes. We also have a way of representing that in ASM. So the group did a lot of work, and Matthias in particular did a lot of work on realizing how to implement that and the right settings, how to use the compression in order to make that work, to bring it down to a reasonable file size without killing the performance, absolutely. Currently, the group's working on ionization types. When we did a review, surprisingly enough, for something that's fairly fundamental to a lot of mass spec, there's not actually a good resource out there for how you classify ionization. There are some, but most of them are pretty light touch and incomplete, and the most complete one, SciMS, turns out to be fairly inconsistent. There are quite a few things there that either aren't ionization types or are very hand-wavy, things like soft ionization. How do you define soft? Being an ontology, sort of a semantic organization with an ontology, we need a little bit more than soft to be able to define things. So currently the team's working on trying to improve that. In 2025 again, we saw mildly tough, so looking to sort of add some extensions for that, and also an MS model I think has been put forward. Matthias is going to be very, very busy next year. For the plate reader group, this year was the addition of kinetics. So we currently have support for 3 detectors: absorbance, fluorescence, and luminescence. So we've added support for reads over time kinetics to those 3 detector types. This quarter, we're basically looking to extend that again to include spectrums, so sort of spectral scans over a wavelength of spectrums, and also looking to add optical imaging, both base optical imaging and fluorescence. So those are in flight for this quarter. And next year, area scans. So we've, I think, more or less got the complete set, at least of the ones that I'm aware of, in terms of scan types over plate readers, and then some clarification on optical spectrometry terms. There's discussions about how we handle spectrograms versus spectrums. So again, semantics, but kind of the job for ontologies. So flow cytometry. This one's a new group. It was started out of the workshop earlier in the year, and as a result, a fair amount of the time this year has been on sort of defining the scope, working out what it is the group's going to do. So reviewing the existing space. There is a de facto standard file format for flow cytometry data, the FCS, and as far as we can tell, basically everything spits out an FCS file. So Allotrope's not keen on reinventing wheels. What's the point in changing that? Where we do think we can see value is the level above that, aggregating those FCS files, sort of where the analysis happens, things that FlowJo and FCS Express do. That's a lot more of a Wild West space. When you go and send your data to a CRO, you get it back in some arbitrary Excel or CSV file format that means absolutely nothing to the person who didn't write it without exhaustive documentation. That's where Allotrope thinks we can make a difference, and so that's where we've sort of defined our focus. This quarter, we're working on basically aligning towards that model, gathering some example data sets. We've been talking about how to represent those gating analyses using the concept of data regions that's been discussed through the last couple of quarters in a few different groups. The intent next year is to have that first release of that model, and then look to extending that and potentially looking into spectral cytometry, which is mentioned as a possible future step for that. And last but certainly not least, the ELN Working Group. Again, another group formed this year, in fact this quarter, so please don't expect too much, we're new. The team was formed. We've been establishing the scope of that initial model. We saw the presentation from Merck and Zontal earlier today, providing that initial use case and that initial model to capture that data. It's a very generic model. It's designed to capture it in its completeness, but as a result, it doesn't have a huge amount of semantics. So the intent is to align that model with Allotrope patterns, so bring those terms into the ontology, make sure all the patterns apply, and then release that for candidate rec in Q4. Happy, Vinny? And then early next year, the first, second quarter, sort of work on a design spec to then extend that model to bring those semantic annotations, the extra context that we think is particularly valuable and useful. Things like potentially the reaction tables, the material tables, anything else that we can identify. So record those in a more concrete, user-friendly way than here is a field and it has a name, here is a value and has a name, have something that's a bit more our standard patterns, a reaction, chemical name this, and roll that, and then start the POC, build it out, test it, see does it work. what are the things that actually need to be in that, with then the view in the second half of the year or somewhere to basically push that model to the candidate rec state and improve it based on those POC outcomes. So that's the summary of the working groups. Thank you for your attention, and in particular, thank you to those who participate in those working groups. None of this would be possible without your input. So thank you to everyone who makes that possible.